Hi folks, welcome to this fifth video in a crash course in counting. So far we've dealt with fundamental counting principle, factorial notation, permutations, combinations. In this section we're going to deal with telling the difference between combinations and permutations, and it all boils down to order. For permutations, the order of the objects matters. So I can't give you some sort of magic bullet for making sure you recognize it every time, but some key words are things like arrange and line up. For combinations, the order of the objects does not matter, it should say. Some key words to look for are things like select or card hands, though it's not a 100% guarantee. You have to make the determination of whether the situation calls for order mattering or not. So for each question, you need to determine whether it's a combination question or a permutation question. And I don't really have any examples here. I just have some questions. So I'll scroll slowly through them. And then I'll go to the answers. And all this stuff is in the PDF that's in the video description. And the answers are where it says mixed here. And for the rest of this video, I'll just go through each of these questions. I'm not going to bother to write out the numerical answer. I'll just write it out as a factorial or a permutation or a combination notation. So tell whether each is a combination or permutation. An arrangement of letters in the word book. Well, in letters, order matters. So this is a permutation. And because there's identical objects, it's actually kind of permutation that we haven't dealt with, but I'll tack something at the end of this counting set of videos that will give you some insight in that. 5 shirts selected from 9 in a drawer. So if you take about 5 shirts to say pack them for a getaway, it really doesn't matter what order they're coming out, at least in my books. I'm just going to pack them in my suitcase. I would think this is a combination. 9 books arranged on a shelf. When they use the word arranged, I would think that order matters. How are we going to arrange them? For biggest to littlest, by color, whatever. How many ways can 6 people be lined up in a row? So this says lined up. The order in a lineup matters. It matters whether you are the first person or the last person. And one way to do this is 6, and you're going to pick all 6. 6p6. You could also do it as 6 factorial, or you could do it with fundamental counting principle. But definitely order matters. In Lotto Super 7, you must choose 7 numbers from 1 to 47. How many different ways are there to fill in a card? So say you're going to choose the numbers, I don't know, my lucky number 7, and you're also going to choose 13 and 3 and 9 and 41 and 12 and 17. Maybe you've never played Lotto Super 7 before. That's fine. That's probably a good thing. But it doesn't matter which one I bubble in on the card first or which one I say first. The order that you select them in doesn't matter. It's just that it's those 7 numbers. So the way that this works out, the total number of ways there are to fill in the card, you have 47 choices, and you can choose 7 of them. And in the last set of practice questions, there was one on Lotto 649 that was very similar. How many ways can 4 letters be arranged? Oh, that's permutation from another. That's 7 letters, 7 pick 4. How many 4 card hands exist with only red cards? So the order that I hold them in my hand doesn't matter. There are 26 red cards, and I'm going to choose 4 of them. Order doesn't matter, so combination. How many 5-person committees can be selected from a group of 12? Okay, so a committee is like a team. Unless there are specific jobs for specific people, then that means it's a combination. The order that they get selected in doesn't matter. So this would be 12C5. A pizza company advertises it has 11 toppings from which to choose. How many different 2-topping pizzas can the company make? When you order a pizza, you don't tell them, I want, pepperoni, and then I want you to put the green pepper on. Now, maybe there is a default order, but it's not something that you stipulate. So order doesn't really matter. And if you really want to argue about this and say, oh, no, I think order matters a great deal on pizza toppings, I guess then you're picking P. How many different 5-topping pizzas can be made? Well, again, I think order does not matter here. If you get a pizza where they put the bacon on before the pepperoni and you send it back and say, I can tell, I don't think they're going to take that very seriously. One of the toppings available is anchovies. How many 3-topping pizzas do not include anchovies? So instead of having 11 to choose from, now you've only got 10 to choose from, and you'll have 10C3. There are 4 vegetable toppings. How many different 3-topping pizzas have no vegetables? So there are 4 vegetable toppings. That means there are 7 non-veggie toppings. And you're saying 7 choose 3 toppings. 7C3. Okay. 2 friends play tennis together regularly. If they decide to play twice a week, in how many ways can they select the days on which to play? So it's obviously 7 days, 7 something 2. Here's my question for you. If you say to your friend, I want to play on Mondays and Wednesdays, and they say, no, I want to play on Wednesdays and Mondays, do you take them seriously? Do you think that they have said nonsense or sense? I think they have said nonsense. Saying you're going to play Monday and Wednesday is the same as playing Wednesday and Monday. You're going to play on those 2 particular days. So the order in which we say or think about the objects does not matter. So this should be 7C2. That brings us to the end of this stuff. In the next video, we'll deal with the words and or in counting questions. I hope this has been helpful. Good luck with the material, folks, and take care.